finally, we have our last section on confidence intervals, and these confidence intervals have to do with variance and standard deviation. So when we are finding the confidence intervals for those, we call this the chi-square distribution. It's spelled like this, but it is pronounced chi with a long I square. Okay, and it's pronounced chi-square because it has the symbol that looks like this, which is a Greek letter. This is the Greek letter chi. Okay, so chi-square distribution is found by taking n minus 1 times the standard deviation squared divided by the sigma squared. So the standard deviation of the sample squared divided by the standard deviation of the population squared. And we use it whenever the random variable has a normal distribution and for any sample sizes where n is greater than 1. Okay? The properties of a chi-square distribution are that all chi-square values are greater than or equal to 0. Because you're squaring something, you will never have a negative number. We create a chi-square distribution family based on the degrees of freedom, similar to a t distribution, where the degrees of freedom is equal to n minus 1. The total area underneath each chi-square distribution is equal to 1, just like other distributions. But here's a significant difference. The chi-square distribution is always positively skewed, so it's skewed to the right. That means the longer tail is on the right. And the chi-square distributions look different based on the number of degrees of freedom. So when it has a low number of degrees of freedom, it has a very high peak with a very long tail. When it has a higher degree of freedom, that peak is going to move over, it's going to get shorter, and it's going to go farther over. So based on looking at this picture, we start with this with a low number of degrees of freedom. Then we get higher and get a little bit higher. And then finally it approaches our normal distribution if the degrees of freedom is 30 or more. So the chi-square distribution is not symmetric. When we're finding critical values for the chi distribution, we have to find the how much area is to the right on the tail and how much area is to the left on the tail, and then subtract those to find our C that's in the middle. The way that we do that is to use these formulas. Okay, so this is for sigma squared. This is for just sigma. Remember, this is for the variance, and this is for the standard deviation. The probability that the confidence intervals contain sigma squared or sigma is C, that's our confidence level, assuming that the estimation process is repeated for a large number of times. So in order to construct it, we're going to use these formulas. First, check and make sure that it has a normal distribution. Find those degrees of freedom. Find your point estimate, S squared, or your sample standard deviation squared. This is for finding the variance. Use the tables in the appendix to find their chi-squared number based on the degrees of freedom and your confidence level. find those endpoints, the left endpoint and the right endpoint for sigma squared, or the left endpoint and the right endpoint for sigma. So let's try it on this example. You randomly select and weigh 30 samples of allergy medicine. So N equal 30. The sample standard deviation is 1.2 milligrams. So S equals 1.2. We're supposed to construct a 99% confidence level, so our C level is 99%. We know that we're creating a confidence interval for the population variance and the standard deviation, so we need to use a chi-square. So our chi-square is going to be equal to, remember that's equal to, well, we got to find the right tail and the left tail one. So if I'm going to go find that right one, it's going to be 1 minus C over 2, or 1 minus 0.99 over 2, which gives me 0.005. And then our chi-square left point, so this would be chi-square right, and this would be chi-square left. Our left point is going to be 1 plus C divided by 2, or 1 plus 0.99 divided by 2, which gives me 0.995. My degrees of freedom is going to be 30 minus 1, or 29. So now using my chi-square left point and my chi-square right point and my degrees of freedom, I can find my critical values. So my chi-square critical value to the right is going to be 52.336 from the table, and my chi-square critical value from the left is going to be 13.121. Those are from the tables in the back of your book. From there, I can create my confidence interval for sigma squared, first by taking my n minus 1, times it by the sample standard deviation squared, divided by my chi-square for my right endpoint, which is going to give me, so 30 minus 1 times 1.2 squared divided by 52.336 gives me 0.80. And for my right, it's n minus 1 times s squared over chi-square to the left, which is 30 minus 1 times 1.2 squared over 13.121, which gives me 3.18. So therefore my interval is from 0.80 to 3.18, which means we are 99% confident that the population variance is between 0.8 and 3.18 milligrams. In order to find the confidence interval for the standard deviation, that means I'm just going to take the square root of each one of those. Square root of 0.80 and the square root of 3.18, which gives me the interval of 0.89 to 1.78. We are 99% confident that the population standard deviation is between 0.89 and 1.78 milligrams. So that's how you do the confidence intervals for variance and standard deviation. So now you're going to be doing 1 through 19 odds on page 348.